I'm Daniella. I'm a researcher at QUT in Brisbane. And yeah, today I'm going to talk very briefly about a project that we have underway at the moment using passive acoustic monitoring for glossy black-cockatoos here in southeast Queensland. And thank you, Kieran, for that wonderful introduction to sound. So hopefully that really kind of set the scene. I won't go into any of those sorts of details. This is much more about how we've actually applied it in a real world sort of monitoring program. All right, I just want to start out by acknowledging that QUT, where I'm based, is on the lands of the Turrbal and Yagara people. And I'd just like to pay my respects to elders past and present and recognise that those places have always been lands of teaching, research and learning. And also just extend my acknowledgement to all First Nations owners on whose land the research that I'm presenting today took place right across southeast Queensland. So just a little bit about my background. So I did my PhD at UQ, graduated 5 years ago. So in that I worked on the bioacoustics of both glossy and red-tailed black-cockatoos, and specifically on the Kangaroo Island subspecies of glossy black-cockatoo and the southeastern red-tailed black-cockatoos down in Victoria and South Australia. And since then, I've been a research fellow at QUT. And at QUT, I'm affiliated with the EcoSounds Lab. So if you are interested in actually applying bioacoustics or ecoacoustics in your work, I definitely recommend you check out the EcoSounds website. And some of the products out of that lab include the Australian Acoustic Observatory, which is an Australia-wide open source continuous monitoring program using passive acoustic monitoring and specifically Frontier Labs solar bars, or the solar powered sound recorders. So we have hundreds of sites right across the continent, including some of the islands, and they're collecting data 24/7, and you can go on there, download it and use it for free. So it's a fantastic resource. We also have the Open Ecoacoustics platform, which is, it's been underway for a while, but it's very much sort of under development at the moment. But on there we have big plans for lots of analytical tools that should hopefully make, life of actual conservation practitioners a lot easier. One of the big things that we'll hopefully be launching early next year includes like automated analyses for Australian birds. So you can basically upload your audio data and just pick the species that you work on, and we can actually process that audio for you free of charge. So watch this space next year. I also have a formal research partnership with Bush Heritage Australia. So actually most of my work is with Bush Heritage, but I won't speak about that today. I'll just be talking about glossies here in southeast Queensland. And before I begin, I just want to say a huge thank you and shout out to the project team. Guy, who's up there, is one of them. So Guy, Gabriel, Mike, Lance, Rob, Beth, Joe, Joel, and the other volunteers who have helped on this project. It's, even though I'm the one up here standing today presenting this work, it is very, very much a team effort. And it's been going on now for 4 years, and we're still got a bit of funding for another year or so. So we've, still got a lot more passive acoustic data coming in. So a really quick background on glossy black-cockatoos for those of you who don't have much experience with them or haven't heard of them. So they are a threatened species, and we do consider them to be quite specialised. They only feed on seeds of casuarina and aloe-casuarina trees. So we collectively term these she oaks. And they actually only feed on some species of she oak, and they actually only feed on some trees of she oak. So even if we have a whole patch of habitat with she oak, there's only a few trees that glossies will actually feed on. So they're very, very specialised in their diet. Like all cockatoos, they need large hollows for nesting. So that's another limiting feature for them. And at the moment, if you look at this distribution map, we can see that there's 3 recognised subspecies at the moment. So we have a northern subspecies, the southeastern subspecies, which is what I'm talking about today. And then down here on Kangaroo Island, we have an isolated subspecies as well. So that's the subspecies I worked on during my PhD, but since then have turned my attention completely to the southeastern subspecies. So the Kangaroo Island subspecies and the southeastern subspecies are nationally threatened under the EPBC Act. We don't really know much about the northern subspecies. Nobody has actually assessed their conservation status. And in fact, there might not even be a subspecies for much longer. There's some debate about this. So watch this space. The southeastern subspecies was listed under the EPBC Act in August 2022 after the Black Summer bushfires. So they were very, very badly impacted in those fires. And then in January this year, we formed the recovery team, which I'm lucky enough to be chairing. And we have a fantastic team, including these two lovely people. Glossies have a very low reproductive rate. So on the mainland, we think that they lay one egg every other year. This is a little bit anecdotal, but that's what we think. And we think that the egg and fledgling mortality is very, very high as well. There's no routine monitoring for glossies at the moment, apart from the odd citizen science project, such as the birding days run by the Conservancy. But yeah, monitoring them is very difficult, and this is partly because they are quite rare and quite difficult to observe. And normally how we find them is through their feeding signs. So I've got a photo here of what that looks like. So they basically snap off the cones off the she-oaks, extract the seeds, and then drop the remains to the ground. We call those chewings or orts, and that is normally how we actually find them in the field. So I have some data here, which is a little bit old. This is from the Conservancy's birding days. And you can see across, a few hundred sites here in southeast Queensland, the detectability is pretty low, 12 to 14%. And that's when we're targeting places where we think that they actually occur. We know they have occurred in the past. So they're hard to find. In our project, we decided to try a bioacoustic approach and see if we can kind of boost that detection probability. And I'd worked in the bioacoustics on Kangaroo Island, so I felt like this would probably work. We have a pretty good understanding of their vocal behaviour, which is something that's quite important, particularly with single species projects. So, we thought we'd give it a crack. And yeah, the end result is that it did work very, very well, which I'll get to. So the aim of our project is to establish a long-term monitoring protocol for glossies to estimate the distribution, habitat use and trends here in southeast Queensland. And we have some specific objectives about actually testing the suitability of bioacoustics as a tool, and then to use that to measure occupancy and feeding habitat, as well as the environmental drivers of occupancy. And this mostly relates to food and fire history. I don't have time today to go into those specific analyses, but if you want to chat about that, come talk to me afterwards. In terms of our study design, so this is a map of southeast Queensland, and what we did was use the Glossy Black-Cockatoo habitat mapping, which you can access on QSpatial, so that's publicly available. We broke it up into 1 kilometre square grid cells, and then we categorised those grid cells by time since fire. And then within each of those categories, we selected 20 sites per category. And this was random. So we did not bias our site selection to any known hotspots. We wanted this to be as representative as possible within this region. So in terms of our data collection, at each site we used 1 Frontier Labs bar LT sound recorders, and that's a photo of them up there. So bar LTs are fantastic. I've been using them and their predecessor, the bars, for nearly 10 years now. And we went with this because, I'm a little bit biased, but they are a fantastic company. It's really great to have, an Australian-based company that if there's any problems with your gear or you have questions, you can just phone them up, or you can pop into their Brisbane store and just talk to them. But most importantly, the sound quality is excellent, and these devices are really robust. So we needed something that could last weeks or potentially months in the field without having to worry about water getting in and that kind of thing. So yeah, we decided with a single sound recorder per site and a recording schedule of sunrise to sunset for 14 days. And this was a little bit arbitrary, but sort of the rationale was glossies are pretty mobile. They don't call a lot for a cockatoo, but we figured over the space of 2 weeks, if we're recording all day, we'll probably find them if they're there. We used a sample rate of 44.1 kilohertz. Again, that was a little bit arbitrary. We could have used a lower sample rate, but we went with this because it's sort of consistent with other work in this region. We also collected a whole range of habitat quality data, which I won't go into now, as well as spatial variables sort of back in the office. Okay, so this is where I want to get into a little bit of the technical details. So hopefully I can explain this clearly. So we just saw Kieran pull up a sound file before in Raven and kind of trawl through it and trying to find the call that he was interested in. And that is fantastic to show, but obviously that's not what we're able to do when we apply acoustics at scale. We need to use some kind of automation tool, and there's plenty of tools out there, and I've probably used and suffered through most of them, so come and talk to me if you have questions about those. But today I'm just going to talk to you about BirdNet Analyzer. Has anyone heard of BirdNet or used BirdNet? A couple people? Yeah. Okay, so BirdNet's fantastic. You can actually download the app on your phone as well if you're just sort of walking around and you want it to ID your birds. But yeah, BirdNet Analyzer is a machine learning tool that is pre-trained on thousands of bird species across the world. It's put out by Cornell Uni. And one of the really good things about BirdNet is that it actually allows you to train your own models on top of its infrastructure. So you can actually use the embeddings within BirdNet and throw whatever data you have for your species at it, and you should actually get a better classifier for your species. So that's what we did for Glossies. And I just actually put a screenshot up here of what the desktop app looks like, just so it's really clear, hopefully, how easy this is to use. So you can go onto GitHub, download BirdNet Analyzer, get this desktop app. This is the entire thing. This is what it looks like, and this is how easy it is to run. So the first thing you need to do is select this option to do a batch analysis. So that's basically if you have more than one sound file, just navigate to your sound files. So they're probably on a hard drive somewhere. Just point BirdNet to that. Set where you want your outputs to go, which if you don't set that, it'll just go to the same hard drive or wherever you have your audio files stored. Specify your confidence threshold. This is extremely important, and I'll speak more about this on the next slide. Then you need to pick which species you want it to find. So you can actually give it a custom species list if you have one. So that could just be like a known site list, or if you're only interested in 5 species, you can just upload that. You can also set species by location. So you just give it the Latin longs for your site. And this basically just refines, it's like basically a filter using eBird sightings data. So you can do that. You don't need to do that if you're picking particular species though. You can use a custom classifier, which is what we did in this project. Or you can say all species, which is literally all species in the whole world. So be prepared for lots of Northern Hemisphere birds turning up on the Gold Coast. No worries. And then select your output type. I always use Raven as my validation tool. We saw Kieran demonstrate what that looks like before. So I just leave this option as a Raven selection table. And then you run it. And that's it. That's literally BirdNet. But like Kieran said as well, we really need to check our data. It's probably the most important thing that I can say today. Don't just trust these tools because they do make mistakes. So there's 2 criteria that hopefully clearly with any machine learning tool, including audio classifiers. We need to think about precision, which is your false positive rate. So this is basically of all the detections that BirdNet finds, how many are actually true for my species, so for glossies in this case. And the formula for that is just those true positives divided by all the number of detections. And on the flip side is recall, which is your false negative rate. So that's about how much is the classifier missing. So in our case of all the Glossy Black-Cockatoo calls in my sound files, how many is BirdNet actually able to find? So they're 2 metrics that are extremely important to think about. Because this issue of, this parameter of confidence, which you need to set as an end user, trades these things off. And you need to decide where in that you want to sit. So that sort of depends on your project objectives. So here's some data from our project. So this is testing BirdNet on a bunch of test files that I have gone through and manually labeled for every single glossy call. And if we just look at this yellow line first, so that's precision. You can see as that confidence score goes up, precision goes up. So those detections that BirdNet is giving me are more likely to be correct. So they're more likely to be glossies. I don't need to go and check as many, which is fantastic, but I need to accept that it's going to be missing some stuff. So we'll have more false negatives. On the flip side, you can see that recall, this beige line, is going down. as we increase that confidence cutoff. So at lower confidence scores, we are going to detect more glossy black cockatoo calls, but I will also get more false positives. So specifically in our case, for our data set, at a cutoff of 0.1, about 80% of the calls in my data set are being detected by BirdNet. So that's fantastic. We're only missing 20%. But more than half of the things it's throwing at me are going to be wrong. So I need to go and spend a lot of time checking it. In our particular project, we focused on maximizing recall. So we actually used a very low cutoff down here. And the reason for this is because in our particular project, for our objectives, I didn't want to miss any calls for a given site on a given day. That was sort of the ultimate metric that we wanted. But in other projects, I just care if the birds are there within a week, then I bump that level up and I'm happy to just find one call a week. Cool, they're there. I don't need to spend much time checking the data. So it's very much about your objectives. In terms of the actual results, so we're almost finished actually analysing the occupancy models at the moment. But most excitingly, we found that glossies are much more detectable with bioacoustics. So just some raw data for you. We saw or heard glossies at 3% of our sites. We found evidence that they're feeding at 9% of sites. And remember, these are random selection of sites with no prior knowledge of if they use them. But we found them in our audio recordings at 33% of our sites, which was amazing, right? That blew our mind. We were like, oh no, like the habitat's not looking that good. They're not going to be here, but they were there. And it still surprises us every time I see this. I'm just blown away by these data. And this spectrogram, I think, really highlights that clearly. So that's a glossy black cockatoo contact call, one of their very, very soft contact calls. And this is a single call given over the space of many, many hours. And if we were in the field, even if that bird was close to us, we probably would miss that call. It's so soft, but the classifier is able to find it. In terms of actual ecological results, I won't sort of go into this in too much detail, but very cool. We found that the more sort of cone density, so more food at each site is more likely to drive occupancy, which is fantastic. That's what we expect, as well as the area of habitat within a landscape around a site. So there's both site level effects and landscape effects, which is cool. Fire history doesn't seem to be playing out as that important. However, we didn't have any fire severity data, which is actually probably the most important thing. We are continuing data collection at the moment. And hopefully, if we can find funding to continue this work, we can actually involve some volunteers in the data collection. That's a long-term goal. And that's it for me. Thank you.
Danny, there was an interesting question from Craig online who wanted to know how do lyrebirds mimicking glossy black cockatoos affect sound recognition?
Excellent question. Yep. Can you guys hear me? Yep. Yeah, really, really good question, and something I actually get asked fairly often. I was talking to someone about this yesterday. It can be really, really difficult. So particularly in our case where we're just dealing with Albert's lyrebird, we tend to actually go into those sound files and look for those like the unique calls that they give. So there's actually like an acoustic sound that lyrebirds give themselves. So ignoring the mimicry, just looking for that particular sound. And it is kind of obvious if you actually listen to the sound file that there'll be like 10 different species in the space of 10 seconds. And it kind of sounds like it's coming from the same place. So you can kind of tell that it is a lyrebird, but it is tricky and the classifier does get it mixed up as well. So
this is from Nicole, who wants to know whether it's possible to do sound recording in planned burn patches prior to the burn to see if there is any nesting present.
Oh, nesting specifically. Yeah, definitely. Yeah, there's nothing that I can think of, from an actual tech point of view that would stop that. It's more, I guess, the logistics and working with the fire authorities. In terms of nesting, the one thing I'll say is that it's quite important to understand the sounds that they make specifically to do with nesting. So if you're just picking up,
a few contact calls or a few flight calls, that doesn't necessarily mean that they are nesting. But we do have a good understanding of their nesting sounds. So I'd be looking for female begging calls, courtship calls, that kind of thing. And if you're very lucky, actual nestling calls, and potentially even fledgling calls, because if they're using that patch right after they're fledged, that's quite important as well. That's what I would say. If you want to know more about the nesting sounds specifically, just flick me an email and I can send you the paper we have where we've actually published all the spectrograms of all their call types as well.
So you're welcome to contact the Glossy Black Conservancy and we'll be able to point you in the right direction.